Greetings everyone, I am Tashukal, ID 2100-1866 from Mechanical Engineering Department.
My name is Khairi Haziq bin Kamaruddin, bearing the student ID 22006589, and I'm from the Chemical Engineering Department.
Hi, my name is Aaron Benjamin Gamang Denker, bearing student ID 22007-105 from the Electrical and Electronics Engineering Department.
Hi, my name is Tuanu Batrisha, student ID 22007267 from Petroleum Engineering.
Hello, my name is Nur Sabrina Minami and my student ID is 22006569 and I'm from Chemical Engineering.
Hello, my name is Intan Batrisha binti Rosli with student ID 22006766 from Chemical Engineering Department.
Today, I'm excited to introduce you to our innovative environmental device, the filter AquaBin. It is designed to float on the surface of bodies of water. The filter AquaBin actively collects and filters debris, pollutants, and microplastic. This cutting-edge solution addresses marine pollution through an advanced filtration system integrated into its mechanism. Our project aligns with Sustainable Development Goal 7, which is SDG 7, established by the United Nations, highlighting the critical role of water as a resource for sustainable energy solutions. By utilizing water for sustainable energy and keeping it clean, we are contributing to a healthier environment and a sustainable future. The Filter AquaBin project addresses several pressing issues. First, waterways are filled with floating trash and dry leaf, which harm fish and other wildlife. This pollution disrupts aquatic ecosystem and poses significant threat to biodiversity. Second, current waste management systems are often ineffective, require constant work and manpower to maintain cleanliness. This inefficiency makes it challenging to keep our waterways clean consistently. Lastly, the presence of debris and organic matter like dry leaf contribute to water pollution, adversely affecting water quality. This pollution can have detrimental effects on both human health and the environment. Our filter AquaBin device aims to tackle these problems efficiently and sustainably.
Several outline mission objectives were determined throughout the execution of the project. First objective, innovation towards improved efficiency. Filtered AquaBin offers validated research and development in pollution control, detection, and prevention. The device can effectively capture, contain, and decontaminate a wide range of aquatic debris and pollutants in the environment. Second, enhanced monitoring and surveillance. A recommendation of providing maintenance to the device once every fortnight is sufficient for continual service from AquaBin. Third, public awareness and education. The presence of AquaBin floating in any water surface will indulge society's perception. In corresponding to this, the accomplishment of having an awareness campaign will be more successful.
Greetings everyone, I'll be explaining the design thinking mechanical parts implemented in this project. AquaBin filtered compartments consist of two sections, which governs as the conveyor belt section and the main body section. Conveyor belt section plays a major role in ensuring the running of this project by using two pipes of the similar diameter. A smooth canvas was applied tightly to both ends. A bigger diameter of pipe was used to hold the top inner pipe. On top of the canvas, a cardboard that was cut into a width of 5 centimeters was glued gun to aid in the lifting garbage mechanism. Motor was used to rotate one of the pipes. The main body, as you can see, consists of the aluminium frame, plastic made basket, two L-shaped metal attached at the sides of the basket, two bottles, and the styrofoam. The aluminium frame was connected by riveting one to another. Basket functions as the garbage collected section, which has two L-shaped metal used to connect other components with the main body itself. Bottles are used as a floating mechanism, whereas the styrofoam also helps in that aspect with the propeller connected at the back of the main body. The technically function scenario of this filtered AquaBin is that the propellers help move the AquaBin forward, backward, left, and right. In addition, the conveyor belt section holds the prominent role by having the motor rotating and lifting the garbages in the basket.
Good day, my name is Aaron Benjamin Gamang Denker, metric number 22007-105 from the Electrical Electronics Engineering Department. In this project, I acted as the main coordinator and also creator of the electrical circuit design, as well as the person in charge of the mechanical connections and the building of the prototype of our project. As part of the electrical electronics engineering department, I was put in charge to deal with all the electrical components of our project. So here are some of the components that we use in our project. For starters, we use the Arduino Uno R3 board. So the use of the Arduino Uno R3 board is to upload the codes that will be used to control the items inside the project. For example, the motors or the batteries and where the outage will be. So I used a program called Arduino IDE, and I programmed in C language to upload all the codes into the Arduino Uno R3 board. And this board was used to provide the information to a motor driver shield that was used to control the motors for the device. Another component that I used was a L293D motor driver shield. This device was put on top of the Arduino Uno R3 board to control the motors that will be used in the project. The motor driver requires an external voltage that is placed into the driver so it can distribute it to the motors following the code from the Arduino Uno R3 board. So this motor driver shield can accommodate 4 motors. However, in our project, we only use 3 motors. So 2 motors were used for the propellers to control the device, and 1 motor was used for the conveyor belt of the device. In this project, I used 3 motors that were connected to the L293D motor driver. So 2 motors were connected to the M3 and M4 of the motor driver, while another motor was connected to the M1 part. So the motor connected to the M1 part of the motor driver was brought to the conveyor belt. It is used to control the conveyor belt speed, which will be used to collect the rubbish from the water. The other 2 motors were connected to M3 and M4 ports of the motor driver shield, and these motors were used as the propellers to control the propellers for the device so it can move in the water smoothly. I programmed the motor driver to provide outputs to these motors in order for it to move properly. To control these motors, I had to download an app called the Arduino Bluetooth controller. So I programmed this controller following the program in C language in the Arduino IDE and uploaded it into the Uno. The up button is used to make the device move forward, and both motors will be running at the same time. Same goes for the down button. When the down button is pressed, the motors will go in the opposite direction and it will cause the boat to go backwards. When the right button is pressed, the motor on the left hand side will go faster than the motor on the right hand side. This ensures that the boat will turn to the right. Same goes to the left. When the left button is pressed, then the motor on the right hand side moves faster than the motor on the left hand side. To be able to control the device via Bluetooth, I had to also connect a HC06 Bluetooth module to the Arduino Uno and the motor driver shield. So the VCC and ground pins of the HC06 Bluetooth module were connected to the positive and negative part of the motor driver shield. Next, I had to solder the TX and RX of the Bluetooth module to the TX and RX of the motor driver shield, which is connected at the 0 and 1 pins. After doing so, when I uploaded the code, I had to include the code in the Arduino IDE to be able to connect it via Bluetooth. To provide external power to the motor driver shield, I had to connect 3 lithium-ion batteries. These lithium-ion batteries were each connected to a TP4056 charging module, which were then connected to a solar panel. So the solar panel receives the sunlight and changes the solar energy into electrical energy to recharge the batteries once it depletes. This is how we use sustainability in our project.
I am Tash Ukal with ID 21001866. So firstly, we conducted an online survey last semester to estimate the cost of materials required for our project. Electrical components were mostly purchased online, while non-electrical components such as frames and pipes were sourced from a local hardware store. Aluminium was selected for the frame due to its lightweight properties, crucial for buoyancy, and plastic pipes were used to reduce weight further. After obtaining the materials, we conducted thorough testing. Electrical components were tested by our team member Aaron, in charge of it, who ensured their functionality. Non-electrical components were assembled to verify fit and compatibility. Our implementation plan involved attaching motors to rollers and securing propellers to styrofoam blocks beneath the prototype. This setup was designed to provide movement and flotation. During fabrication, we started with the frame using the Albracket aluminum. Each piece was measured, cut, and smoothed with a file and sandpaper. Rivets were used for joining the frames due to the lack of aluminum welding tools in the workshop, and metal glue provided additional reinforcements. The frame stability was enhanced by using pre-made L-shaped brackets, and plastic bottles were used as flotation devices to keep the prototype afloat. The electrical components were chosen for their reliability, cost effectiveness, and user-friendliness. We tested the prototype in a nearby lake using plastic bottles to simulate rubbish. Buoyancy was achieved using a styrofoam box and empty plastic bottles, and propellers were connected to an Arduino motor driver and attached to the styrofoam plate underneath the prototype. To protect the electrical components from water, we stored them in a waterproof box and sealed wiring joints with electrical tape and glue gun. The belt mechanism was created using pipes as rollers and motors for movements, with bunting material chosen for the belt itself. Initial testing revealed buoyancy issues, which were addressed by adding more styrofoam to the base plate. This adjustment improved the prototype's buoyancy. After several tests and modifications, we recorded the results and finalized the prototype design, and this process underscored the importance of thorough testing and iteration.
The material chosen for our filter AquaBin ensure optimal functionality and efficiency. We use a banner for the conveyor belt because it is lightweight, aiding in buoyancy and maneuverability. Also, water bottle as a floaters at the both sides of the AquaBin to keep the prototype afloat, ensuring stability on the water surface. Also, a waterproof box was attached at the back of our prototype to protect the electrical components, preventing water damage and ensuring reliable operation. Lastly, the propeller also provide the necessary thrust for navigation that allow the AquaBin to move towards and around the base efficiently. Our project aims to combat water reservoir pollution in Malaysia with the innovative design of the filter AquaBin. This device is specifically designed to maximize efficiency on the water surface that featuring a hood-like structure that ensures ease of navigation and a front net that effectively gather the breeze. In terms of result, our filter AquaBin has demonstrated excellent floating capability while also maintaining stability and buoyancy on the water surface, as you can see in the video later. It has proven effective in lifting lightweight objects such as water bottles, plastics, and so on.
So this is the working mechanism of our project with the Bluetooth connected to the propellers, as you can see here. And there are two propellers to indicate the back to move the project, and that one on the left hand side is to move the conveyor belt. So if the up button is pressed, the back propellers will move, and if we press the down button, it will go in opposite direction. If the right was pressed, one motor will stop while the other runs, and same goes for the left hand side button. And when press pause, both motors stop. When triangle is pressed, the conveyor belt starts working. This is just an indication. When X is pressed, then the conveyor belt stops.
The economic consideration for the filter AquaBin include capital and operational costs. The capital cost is RM303 per unit, that covering the plastic basket, nylon net, conveyor belt, water bottles, and so on. For the operational costs, we set the price at RM110 per service, which include the water filter and scheduled maintenance. For the selling price, we set at RM597 per unit, which quite affordable because it includes 24/7 support, ensuring value and reliability for our customers.
In conclusion, the Filter AquaBin project has developed a new and effective way to deal with waste pollution in lakes and other water bodies. Our main goal is to manage waste in a way that keeps water clean and prevent harm to the environment. The Filter AquaBin not only captures and removes waste, but also helps keep our water ecosystem healthy for the future. To make sure this project is practical, we conducted a detailed study. This study looked at the business and economic factors, including the cost to start and run the project, as well as different material used. The Filtered AquaBin project shows our dedication to protecting the environment and promoting sustainable practices, thus can make a big difference in reducing water pollution and protecting our valuable water resources. To ensure the success and sustainability of this project, we have several key recommendations. First, we recommend deploying the Filtered AquaBin solution widely to prevent environmental harm and maintain water quality. By using this innovative technology, we can significantly reduce waste pollution in our lakes and other water bodies. Second, we suggest collaborating with local communities, government agencies, and environmental groups. This partnership will be crucial for the long-term sustainability of the project. Working together, we can ensure that the filtered aquabin are installed and maintained properly. Third, we recommend continuously assessing the solution's effectiveness. As environmental conditions change, it's important to monitor the performance of the filtered aquabin and make necessary improvements. This ongoing evaluation will help us adapt to new challenges and ensure the project remains effective in the long run. By following these recommendations, we can maximize the positive impact of this project.